Static indeterminacy is like solving puzzles. Imagine a puzzle with more pieces than needed to complete it. In structural engineering, static indeterminacy means a structure has more support than necessary to stay in place. It is like having extra puzzle pieces that don't fit. Structural frame reactions result from actions on a frame. Think of a frame as a giant picture frame holding up a painting. To keep it balanced, we need to figure out how much force each corner of the frame is holding or pushing. These forces are called reactions, like the frame's grip on the painting. In short, static indeterminacy is like solving puzzles, and finding structural frame reactions is same as making sure picture frame don't drop our paintings.
Hey friends, if you're new here, I am Dr. Jawed Qureshi, a senior lecturer at a London university. On this channel, we explore technical and human skills to help us lead more productive, happy, and examined life.
The learning outcomes of this lecture will be that you will be able to determine static determinacy of frames and carry out the analysis of 3-pin frames and simply supported frames. There is a difference between a beam and a frame. A frame is a combination of columns and beams. Most of the time the joints are rigid. Some joints could be pinned as well. A frame can have axial force, it can have shear force, it can have a bending moment as well. In today's lecture, I will simply cover how do we work out reactions. Now, determination of static indeterminacy. If we are analyzing a structure in 2 dimensions, which we are, it means that x and y direction, there are 3 equilibrium equations to take care of it. Number of unknowns should be equal to number of equilibrium equations for it to be statically determinate. If it is not, if the number of unknowns is more than equilibrium equations, then it is statically indeterminate. If it is equal, then it is determinate. Now, how about if it is less? So if number of unknowns are less than equilibrium equations, then what will happen? What do you think will happen? Take example of 4-legged stool and take example of 3-legged stool. So 4-legged stool will have 4 reactions. If it has got 3 legs, then it will have 3 reactions. If it has got 4 legs, it will have 4 reactions. So this structure on your right is statically indeterminate because it has more unknowns than equilibrium equations. A 3-legged stool, on the other hand, is determinate structure, which means that the number of unknowns are equal to number of equilibrium equations. When unknowns are less than equilibrium equations, then we say that this kind of a structure is mechanism or collapse. A good example is that if you leave a bike without third support, then it will collapse, will it not? The only exception could be a human body, because a human body has got 2 reactions under its feet. That is an exception, all right? So you can say to me that, okay, what about human body? Human body is fine, but when we move, I mean, certainly our body has got flexibility to move our arms in a way that we do not destabilize. So we can say that if unknowns are equal to equilibrium equations, structure is determinate and it is stable. And if unknowns are greater than equilibrium equations, then structure is indeterminate but still stable. Or we could say that structure is redundant. It means that there are more members than needed in a structure. What are these equilibrium equations? There are 3 equilibrium equations for any structure in this world to be in equilibrium. One is summation of horizontal forces equal to 0, summation of vertical forces equal to 0, and summation of moment equal to 0. Now, this is one example of frame where you can see that bottom support is fixed, horizontal load is applied at point B, and joints B and C are fixed joints or built-in joints. For each joint, there will be 3 unknowns. You know that for a fixed support, there are 3 unknowns, aren't they? So there are 3 reactions. For each member, there will be 3 unknowns. So members will have 3 internal forces as well. So N, V, and M. We can say that for a portal frame or a fixed jointed frame, members will have 3 forces. horizontal, vertical, and moment. Joints will also have three forces: horizontal, vertical, and moment, and everything is fixed together. We'll try to find out static indeterminacy. But before that, I would like to give you some revision of the reactions of the supports. Fully fixed support will have three reactions: a horizontal force, vertical force, resisting moment. On the other hand, a simple support or a pin support has two reactions: a horizontal force and vertical force. Roller support, on the other hand, has got only one reaction, which is a vertical force. So it can move in horizontal direction both ways, and it can rotate. Now, what formula do we use to work out degree of static indeterminacy? The formula is m plus r minus f minus 2j, where m is number of members and r is number of joints. Now, these joints are between members and between members and supports. F is roller release. So if you have a roller support, you will make one release for that. J is number of joints other than supports. This can only be applied to 2D structures. It takes into account both support conditions and internal releases contained within the structure. The internal release, often referred to as pin, it may be visualized as hinges within the frame. Now this structure has got a pin over here. This is internal pin. So this formula will take into account of that internal pin. The pins and hinges provide a further equation for solution, as the sum of the moments at the pin must be equal to 0. A pin cannot take any moment. Now you can visualize a pin or hinge like a door hinge. When you try to open a door, it will rotate. So hinge has no resistance to moment applied. This is termed as simple beam to column connection. It's very useful in steel design, and no moment is happening because of pin joint. Another example is that you have small leg angles placed here, and then it is bolted to the column, and then here it is bolted to the beam. And then you can see that when you apply loading to this beam, it will rotate over here. This gap will facilitate that rotation. Now, example 1 is a portal frame. Now here we have a fixed support at A. The joints at B and D are rigid joints. And again, we have a fixed support at E. But there is one internal pin over here at C, which is actually dividing it into two members. So one is member BC on the left side, other is member CD on the right side. And they are connected with single bolt connection. Because of this pin, all the moments are released at this pin. And remember our formula m plus r minus f minus 2j. Firstly, we have to count number of members. Because of this internal pin, it is dividing this member BD into two members. In total, we have 4 members. The number of rigid joints will be 4. Joint 3 is not rigid, it's a pin. Number of roller releases, we do not have any roller support. And number of joints, not including supports. So these are 3 joints. Now m plus r minus f. M is number of members, which is 4. R is number of rigid joints, which is 4. F is roller releases. We do not have any roller support. Minus 2 times J is number of joints, not including supports. Now this will give me 2. SI, or static indeterminacy, is 2 degrees. Now I will move to 4-pin frame. First of all, we have to count number of members. The number of members are 3. Number of rigid joints is 0. Because we have pin at A, pin at B, pin at C, and pin at D. So we don't have any rigid joints. The number of roller releases, we do not have any roller over here. And number of joints, not including supports, we have 2 joints, B and C. Now if we put all this information here, m plus r minus f minus 2j, and then you can see that this is mechanism. Why it's mechanism? Because when you apply a horizontal load, because it can rotate at B and C, it will simply move away in lateral direction. What will you do to avoid mechanism?
Replace the pin supports.
Replace the pin support. This is one option. Well done, excellent. What could be other option? How about if I increase number of members? How about if I introduce one more member over here? That will increase the number of members. If this is 4 instead of 3, then you will get 0, will you not? 3 pin frames, as you have guessed, SI is going to be 0. This means that we can analyze them using the methods that we already know, that is equilibrium equations. And remember that vertical forces are positive upwards and horizontal forces are positive rightwards, and moment is clockwise positive. Calculation of internal forces, we have axial forces, we have shear forces, and we have bending moment. And remember that if we are starting from left side, upward shear forces are positive and clockwise moments are positive from left. The reverse is true if you are starting from right side. Downward is positive, rightward is positive, and anti-clockwise moments are positive. And then you have this internal force diagrams. Now, axial forces and shear force diagrams are drawn positive on the outside of the frame, and they are drawn negative inside of the frame. On the other hand, with moment diagrams, positive value should be drawn inside because the tension side of the member is inside, and negative values or negative moments or hogging moments are going to be drawn outside of the frames. I would like to cover very simple examples. So first thing first, to solve this kind of structure, you need to find out its SI. But here, because we have already done it, this is a simply supported frame. We know that its SI is equal to 0 already. I will say summation of horizontal forces equal to 0 and summation of vertical forces equal to 0. Support A will have 2 reactions and support B will have 1 reaction. RAH is equal to 0 because there is no horizontal force applied. Second is summation of vertical forces Fy equal to 0. RAV plus RB equal to 20 kilonewton. Third one is summation of moment at B equal to 0. RAV times 3, and that's going to be clockwise, and minus this force is going to create a moment 20 times 1 equal to 0. So this will give me RAV 6.67 kilonewton. And if I put this back into this equation, I will get 13.33. There are 2 horizontal forces. I would say that HB equal to 10 kilonewton. So summation of moment at B equal to 0. You will start with VA times distance between A and B is 6, 10 kilonewton. This 10 kilonewton is generating clockwise moment with respect to B. Distance between this force to support A is 2, and from the overall distance is 6. So which means that distance from this horizontal point load to B is 4. And then minus this 20 kilonewton will create anti-clockwise moment. So 20 times 3, this is equal to 0. Then I will use summation of moment at A equal to 0. VB times 6 negative 20 times 3. That will be plus actually, okay, because this will create a clockwise moment with respect to A. 10 plus 10 times 2, because distance from 10 to point A is 2. It will actually create a clockwise moment, and distance is 2 from this point B to A. So value of HP is 10. This is HP. So this will be 100 divided by 6. So this will give us 16.67 kilonewton. Now if you add everything, 16.67 plus 3.33, you will get 20.
Thanks for watching this lecture today. Click on left side of the screen to watch another video relevant to this lecture. Click on right screen to watch full playlist on structural mechanics.